Hello, space travelers. I'm Austin Jordan, head of marketing and communications at Redwire Space. And today, I'm on the International Space Station, and we're going to... Come on. All right, I'm not on the International Space Station. I'm actually at Redwire headquarters in Jacksonville, Florida. Honestly, between you and I probably couldn't cut it as an astronaut because I'm scared of heights. But let's keep that a secret. Anyway, we're still on an exciting mission, and if you're down to join me, let's check it out. Come on. Okay, here at Redwire Space, insert company logo here, we love to empower students to become future astronauts, engineers, and scientists. And to celebrate the release of Marvel Studios' Guardians of the Galaxy Volume 3, we teamed up with Microsoft and Marvel Studios to launch the one and only Zune music player to the International Space Station. And this is the same one that Star-Lord uses, so it's the real deal.
Redwire, take one. A Zune is Microsoft old MP3 player. Just plays music whenever you want it to.
Let's cut to the chase, people. The real important question is, do you know how we sent the Zune player to the International Space Station? Oh, so you think you have it? Wait, what? No. Come on, we don't have the budget for that. I think there's a better way. How about 3D printing? But what exactly is 3D printing?
3D printing is a type of manufacturing in which you add material instead of taking it away.
It's like a piece of paper. If you cut it out in the shape and then you stack those shapes up, eventually you'll get a 3D object in whatever shape you want.
But 3D printing in space? Not as easy as it seems. Space lacks one important element that we have here on Earth. Do you know what that is? You got it. Here on Earth, we have gravity, the force that attracts everything to its center. So, what happens when we try to 3D print in space? 3D printing will take space exploration to the next level with the ability to manufacture parts and tools right up there in orbit. Of course, as with any great adventure, there are several challenges to overcome.
Without gravity, you lose thermal convection, so heat doesn't rise, heat stays where it is.
It's like when you put a ball filled with air inside a tub of water, it'll float to the top. The same thing happens with the density differences of different temperature air. And on the ground, because there's gravity, that'll float to the top. In space, there isn't a top, so that won't happen without forcing it yourself.
And so Redwire has come up with the first 3D printer to operate in low Earth orbit. And it's called AMF, which obviously stands for awesome, magnificent, and fabulous. All right, I'm just kidding.
AMF is our additive manufacturing facility on the ISS. It's the 3D printer that we use to manufacture parts on demand for the space station.
These capabilities are crucial to enabling a sustainable human presence in space that is not reliant on resupply from Earth. The idea is you can print whatever you need. Spare parts, tools, equipment, whatever we couldn't bring on the trip to begin with.
If things break, if they need something new, the only path is to make it there. And 3D printing is one of the most flexible ways to make things which hold shape.
And with a little preparation, you won't even have to worry during longer space missions.
You send up your material, and then you build it up there. You can build them right away instead of having to wait for the next rocket. Make a tool, use the tool, then recycle the tool into a new tool, all with the same material in hand.
This is all very interesting, but something's been nagging in the back of my mind. I wonder if we could print pizza.
No, can't currently print pizza in space, no.
3D printing is not only helpful in case you need a spare part, it has many more applications. Like right now, Redwire is working on 3D printing with lunar regolith. I'm talking moon dirt. And we're even working on bioprinting human organs. Yeah, like real science. Yep, that means we're taking the fiction out of science fiction in more ways than one.
Core technology of AMF is applicable to lunar infrastructure manufacturing, additively manufacturing roads and landing pads on the moon, to in-space bioprinting, as well as through polymers and soon metals.
And one thing is certain, we are literally creating a future where people can live and work, and thanks to this awesome music player, party like it's 2,999 up in space. Now, let's talk about our mission. How are we going to send this little device to the space station? To help me demonstrate, I've got my friend Terry the robotic arm. On Earth, we would scan our zoo, and then we would send that information to the space station. On the ISS, Redwire's Space 3D printer would successfully print the Zune, and then voila, a 3D printed Zune. Thank you, Terry. Good robot. Now that we know how everything works, why don't we go see the real process from start to finish? Yes! And it all begins in this room with a lot of screens.
Welcome to the Space Operations Room here at Redwire in Jacksonville, Florida, and this is where we do all of our operations for the additive manufacturing facility on board ISS.
This 3D printed Zune, just like the one seen in Marvel Studios' Guardians of the Galaxy Volume 3, will be proof that 3D printing in space is not only very cool, but also very real. And it will help humanity get to the moon, Mars, and beyond. Whew. Okay, that was amazing. I think we can all agree that our mission today was accomplished. And to all of you future astronauts, explorers, scientists, continue the journey on redwirespace.com and learn more about our upcoming projects. As for me, I'm headed back to the International Space Station. Ah, come on, not again. Terry!